Hi guys, my name is Great. Welcome to TIC. Today I'll be treating the topic hypothesis testing. So before we treat that, let's know what hypothesis means basically. So hypothesis is a claim or premise to be tested or to be verified or to be validated. Why hypothesis testing refers to the assumption about a population parameter. Now, from the definition of hypothesis, we say that it is a claim. Now, let's treat what is a claim. A claim is basically a statement or assertion that something is true, typically without providing evidence. Now, a claim can either be subjective or contain information of a numerical value. Now, let's look at some examples depicting what I've just said. Covenant University, the best university in Nigeria. Let's look at example 2. 95% of the students in Covenant University have a 5.0 GPA results every semester. Well, that is also a statement. We don't know whether it is true or false, but that's when hypothesis testing comes in place, whereby you have to test if it is true or if you have to accept the claim or refuse to accept the claim. Now, the third example. On the average, Covenant University students get 100,000 per month as pocket money. Well, we don't also know whether that is true or false, but all we know is that it's a statement that has been said by somebody. From the examples, the 5 examples listed, let's segment them into the two claims I talked about. Now, example 4 says, Hebron make out the best pure water and quality bread. Well, that is subjective. Why did I say it's subjective? Because it can be the personal opinion of somebody. Subjective meaning that it is your own personal opinion. It's not like it's something that is generally accepted. So I can say Hebron, example 4, as I've already said there, Hebron make out the best pure water and quality bread. Now let's look at another example of when a claim can be subjective, which is example 5. Covenant University, the best place to grow spiritually and excel academically. Is my personal opinion basically. That's why it was classified under claims that are subjective. Now let's look at claims that contain information of a numerical value. Now in example 2, it says 95% of students in Covenant University have a 5.0 GPA results every semester. Well, numerical figure 95%. Let's look at another example. Example 3, which says on the average, Covenant University students get 100,000 per month as pocket money. Well, numerical value, that's 100,000. So in essence, I'm trying to say that a claim can either be subjective or it can contain numerical value. So in summary, hypothesis testing has to do with carrying out an investigation which ends in either rejecting or accepting. Hypothesis testing can never prove that a statement is either true or false. It can only give a measure of truth or otherwise of a given statement. So now we'll be looking at population parameters. Now, where these population parameters come from? Remember from the beginning, I said that hypothesis testing refers to assumption about a population parameters. So that's where this population parameters is coming from. And remember, when you're doing your investigation, you're not just investigating an object. You're using maybe students or a particular population to get your sample basically, or to get whether your statement is true or false, or whether to accept a particular statement or reject it basically. So now, what is a population parameter? A population parameter is the descriptive measure or characteristics of an entire population which provides important information about a population as a whole. Now note, to test whether a claim or premise is true or false, we carry out a survey on the population, as I already explained from the beginning. Now, in getting population, you get population mean, population variance, sample mean, and sample variance. Now, population mean is denoted by this sign. Please take note. Why population variance is denoted by that sign? Why sample mean is denoted by this? And why variance is denoted by that? Now we'll be looking at the types of hypothesis. Now, hypothesis testing is divided into two, which are the null hypothesis and alternative hypothesis. Now let's look at the definition for null hypothesis. Now, before we look at the definition for null hypothesis, we need to note that null hypothesis is denoted by H subscript 0. Now, what is null hypothesis? It is the hypothesis of primary interest that you accept or reject. It is the hypothesis that is tested, basically. We can also define null hypothesis as the assumption about a population parameter, such as population mean. Now, the basic thing I want you to take note about null hypothesis is that it is a statement of equality. It says population is equal to this, to some value. Okay. Now, another thing you need to note is that null hypothesis is denoted by, H subscript O, as I've said. But remember, we said null hypothesis has to do with equality. So that is also denoted by an equals to sign. So let's look at an example. Hebron Company makes a claim that their Hebron water is 75 cl in each bottle. Now, this establishes the null hypothesis, that is H subscript O. Then you put your sign, then the population mean, this is called the population mean, equals to 75 cl. Now, let's look at the other type of hypothesis, which is alternative hypothesis. So basically, alternative hypothesis is denoted by the sign H subscript 1. Now, you need to know that this alternative hypothesis is the opposite of the null hypothesis. For the null hypothesis, you are saying your statement, your claim is this. But for the alternative hypothesis, it will be the opposite of what you are saying. Alternative hypothesis plays a small part in the test procedure and is not the hypothesis that is tested. So now, for alternative hypothesis, it is the hypothesis that is adopted if H subscript O is rejected, basically. As I said, because I said it is the opposite of null hypothesis. For alternative hypothesis, it is not going to have an equals to sign as the null hypothesis. Instead, it is going to have either greater than, less than, or not equals to. Now let's look at an example under alternative hypothesis. Suppose, remember from the beginning, we were given this. Hebron Company makes a claim that their Hebron water is 75 cl of the water in each bottle. Now, for the alternative hypothesis, suppose you now carry out an investigation, okay, and it reveals that the volume of Hebron water is either less than, greater than, or not equal to 75 cl. In that case, the claim made by Hebron Company is deemed incorrect, because here you have already carried out that investigation and you found out that here is the opposite of what Hebron Company has already said. They said their water is 75 cl, but when you carry out your investigation, it can turn out that it is less than 75 cl, or it is greater than 75 cl, or it is not equal to 75 cl at all. That is when alternative hypothesis comes in place. Now, when you have carried out that investigation, it will now be written as this, which is H subscript 1, your sign, then your population mean is not equal to 75 cl. That is when it is not equal to 75 cl. But if it is greater than 75 cl when you carried out your investigation, it will be denoted as H subscript 1. Then your population mean is greater than 75 cl. Now let's look at errors in hypothesis testing. Now we have two types of errors, which is the type 1 error and the type 2 error. So basically, the type 1 error is an error that occurs when you reject a correct hypothesis. Now, the probability of committing a type 1 error is called alpha risk. Please take note of that. Then we're moving on to the second type of error, the second error in hypothesis testing, which is type 2 error. Now, that is when we accept the null hypothesis when it is false. So now, take note. The probability of committing a type 2 error is called beta risk, your level of confidence. Now, level of confidence is basically talking about how confident we are in our decision. Okay, it talks about how sure we are in making the right decision. Now, you can put your level of confidence to either be 90%, 95%, or 99%. It depends on the question that is given to you. But you yourself, you should know when your level of confidence is 50%, you should know that that statement that has been made is faulty. something like that. You get? So now, let's move on to the level of significance. Now, the level of significance is denoted by the alpha sign. So when you see an alpha sign, you should know that they are talking about what? The level of significance. So now, in your question, when you're given a question, you can be given a confidence level instead of a level of significance. Okay. Now, what you are going to do is you are going to do your alpha denoting your level of significance is equals to 1 minus your confidence level. So if your confidence level is 95%, what do? You do 1 minus 95% to get your what? Level of significance. Note, the level of significance is set before conducting the hypothesis test and is used to determine whether the evidence against the null hypothesis is strong enough to reject it. Now, commonly used level of significance are 0.05 and 0.01, indicating 5% and 1% chance of making a type 1 error, respectively. Now, popular level of significance are, as I've already said before, 0.1%, 5%, 10%. But in hypothesis testing, is written as 1% is written as 0.01, 5% is written as 0.05, and 10% is written as 0.1. At level of significance, when your level of significance is 0.05, we are 95% confident that we have made the right decision. Now we'll be looking at test statistics. Now this test statistics is also known as calculated value. So it's divided into two. That is your t-test and your z-test. So now the formula for your z-test will be your sample mean. All these symbols here are your population parameter. Remember at the beginning of the lecture, I told you that we have population parameter. In the course of the lecture, you'll be dealing with all these things. So now the z-test is your sample mean minus your population mean divided by your standard deviation. That is your population standard deviation divided by square root of your number. That's n. Now, why for the t-test? It will be your sample mean minus your population mean divided by your sample standard deviation divided by your square root of n. Now, when do we use z-test statistics? We'll be looking at the conditions necessary for using this z-test. Okay. So now, it is used when the sample size is large. It is typically when it is greater than 30. The z-test is also used when the population variance is known. Please take note. It is also used when a population follows a normal distribution. The z-test is a standard normal distribution with mean of 0 and variance of 1. When do we use t-test? That's the next thing we'll be looking at. That is the condition necessary for using a t-test. Now, a t-test is used when the sample size is small. Please take note. And when is the sample size small? That is when it is less than what? 30. A t-test is also used when the population standard variance is unknown. A t-test is also used when a population follows a normal distribution and has degree of freedom. Now, degree of freedom has a formula. What is the formula for degree of freedom? That is basically n minus 1. Now, let's look at the formula for a t-test. Remember, we already discussed that before, but I would like to expatiate more on it because in the formula, there are other formulas that will be derived from it also in order to get the t-test. So, for example, now, the formula for t-test is equal to your sample mean minus your population mean divided by your sample standard deviation divided by square root of n, which is your sample size. Now, you must take note that, first of all, before I go deeper into it, please take note of these two things. For the z-test, in the formula for z-test and t-test, the difference between them is the standard deviation. Remember, both of them have sample mean. Please take note. Both of them have sample mean minus population mean divided by. Now, the difference is the standard deviation. Now, the sign for the standard deviation are both different. But what differentiates them is that for z-test, your standard deviation is not just standard deviation. It is population standard deviation. But for your t-test, your standard deviation is sample standard deviation. Do you see the difference between them? Yeah. So now let's dive deeper into the t-test. I've already given you the formula for t-test. Now, in order for you to get your sample standard deviation for your t-test, what you do is you find the variance, then you square the variance to get your sample standard deviation. Now, the formula for finding that sample variance is summation x minus sample mean, put them in brackets, raised to power 2, divided by your level of freedom. Remember from the beginning, I told you that your level of freedom is what? N minus 1. Now, sample variance has two formulas. The first formula that I told you is the first one. Now, let's look at the second formula for sample variance. That will be summation x squared minus summation x, put it in brackets, raised to power 2 over n, divided by your level of freedom, which is denoted by what? N minus 1. Now, for the one day test, it gives direction and reflects the silentness of the test. What do I mean by that? Greater than, it is to the right. Less than, it is to the left, but not both. So let's look at what we have. One day test is known as directional hypothesis test. It is a type of hypothesis test where the alternative hypothesis, I didn't say where the null hypothesis, I said where the alternative hypothesis is formulated to detect an effect in a specific direction, either greater than or less than, but not both, compared to the null hypothesis, which is just denoted by, okay, let's move on. In a one-day test, the focus is on determining if a parameter is either greater or less than a specific value, but not both, by looking at one tail of the distribution. Now note, one tail test is divided into two, which is the upper and lower tail test, and they reflect the silentness of the test. Now let's look at an example under the upper/right tail test. For example, now let's say your null hypothesis is equal to 65, while your alternative hypothesis is greater than 65. If you look at the graph, it will be at the right hand side. That's why we see that the right hand side is shaded. Now this is known as normal distribution graph. Normal distribution graph. That's why we can see that this because it's greater than, okay, it will be denoted, it will be, I mean, the right hand side of the normal distribution graph is shaded. And now, why did I say it's upper tail? Because it is, that's greater than signifying more than. That's why it's called the upper/right tail test. Now let's look at lower tail test. For example, now, when your null hypothesis is equal to 65 and your alternative hypothesis, which is denoted by H subscript 1, is less than 65. On your graph, that's your normal distribution graph, okay? It will be denoted at the left hand side. Do you get? And the reason why we're calling it a lower tail test is because the less than sign is there. That's why it's called a lower tail test. Now let's look at two tail tests. Now for two tail tests, it is non-directional. It does not give you a particular direction as your one tail test, which gives you a particular direction. It is a type of hypothesis test where the alternative hypothesis, note again, I didn't say where the non-hypothesis, where the alternative hypothesis is formulated to detect a difference, but not a specific direction of the effect compared to the null hypothesis. Now let's look at an example. Let's say your null hypothesis is equals to 1200. The alternative hypothesis will be is not equals to 1200. Now, is it giving us a direction? The answer is no, because it's not telling us whether it is less than or greater than. It is saying it is not equals to, so it is non-directional. It is a two-tailed test. Now, when you look at a two-tailed test in the aspect or in the area of a normal distribution graph, it is showing the left hand side and the right hand side shaded. meaning that it is non-directional. Next, we'll be looking at how to get the critical value for one-tailed test and two-tailed test. Remember, we're dealing with z-test. In order to obtain the critical value, you must be able to interpret the type of test to adopt, which is either one-tailed test or two-tailed test. It cannot be both. For one-tailed test, how do you identify whether it's a one-tailed test? It is when it is either greater than or less than, but not both. But how do you denote whether it's a two-tailed test? It is when no direction is given. It is, for example, not equals to. You get. So now, the first step, how do you get the critical value for a one-tailed test? You must be able to interpret the type of test to adopt first. The second one is you must be able to identify your level of significance, which is denoted by your alpha sign, what we discussed about earlier. The third step is for a one-tailed test, you subtract the level of significance given from 0.5. 0.5 is constant. You get? 0.5 is constant. So you subtract your level of significance from 0.5. Then next, you then check your table, which is your z-test table, for the number given, then add them together. Now let's look at an example on how to get your critical value for one t-test. Now in this example, we're giving our level of significance to be 0.05 and we're giving our null hypothesis to be greater than 67, and it is a z-test. Remember, how do we know whether it is in a z-test situation? How we know whether it is in a z-test information is when our population variance is given in that question, is known. But if it is not known, we use the t-test. It will be in a t-test situation. That's why I identified it there, z-test. Now, the answer, how do we get the critical value? From the first, I said what? You must be able to interpret the type of test to adopt. Now, from the question, we have identified that it is a one-tailed test. Why? Because it is directional. It is showing the direction, which is greater than. Now, step 2, we said you identify your level of significance. And in this question, our level of significance is given to be what? 0.05. The third step is that you subtract it from your constant value, which is 0.5. So when you subtract it, you get 0.45. Now, step 4, you then check your table, which is your Z table, for 0.45. Now, when you check your table for 0.45, you are going to get 1.6 horizontally and 0.05 vertically. Now, when you get that, you add them together to get your critical value, which is 1.65. Next, we'll be looking at how to get the critical value for two-tailed test in a z-test situation. Now, the first step is you must be able to interpret the type of test to adopt, which is either one-tailed test or two-tailed test, cannot be both. The second step is that you must identify your level of significance, which is denoted by your alpha sign. In the question that you'll be given, your level of significance will be given. And if it is not given, then that means your confidence level will be given. So you have to find that level of significance. Now, in order for you to find that level of significance, you do how far, which is representing your level of significance, equals to 1 minus your confidence level to get your level of significance. Now, the third step is that for a two-tailed test, you subtract the level of significance, which will be divided by 2 from 0.5. When we're dealing with one tail, we said 0.5 is constant. So we do 0.5 minus our level of significance. But now it is a two-tail test. So what we're going to do is divide the level of significance by 2. Then you now minus it from what? 0.5. Now, the fourth step is that you then check your table for the number given, then add them together. Remember, why are we using our z-test table? We could have just used our t-test table. But in this scenario, the z-test table is used because our population variance is given. Now, let's look at an example denoting all I've said. Now, in this question, we're given our null hypothesis to be not equal to 67 and our level of significance to be 0.05. And this is in a z-test situation. Now, we're asked this question: find the critical value for this. So what you are going to do is your step one is that you first of all identify the type of test to adopt. Now from this question, our null hypothesis is not equal to 67, denoting that it is a two-tailed test and it is non-directional because it's not showing whether it's less than or greater than. So that's why, so now we have identified what? A two-tailed test as our step one. Step two, we said you what? You state your level of significance. And from the question, our level of significance is given as what? 0.05. Step three, remember I said because it is a two-tailed test. How do we know it's a two-tailed test? Through the sign that was given, which is not equals to. Now, because it is a two-tailed test, what we're going to do is that you divide your level of significance by 2. And when you divide it and get your answer, you subtract it from what? The constant value, which is what? 0.5. Now, from this question, our level of significance is 0.05. So what we're going to do is that we divide it by 2 and subtract it from 0.5. So now, from the question, we have our level of significance to be 0.05. So 0.05 divided by 2, you get 0.025. Now we've gotten this answer. What are we going to do next? We subtract it from the constant value, which is 0.5, to get what? 0.475. Now, if you check your Z table for 0.475, you will see 0.06 vertically and 1.9 horizontally. Then when you get these figures, what are you going to do next? You then add them together to get your answer. That will now be 0.06 plus 1.9 equals to 1.96. So our critical value for this question is what? 1.96. So now we'll be talking about how to find the critical value for one-tail test and two-tail tests. But now we'll be looking at it in a situation whereby we're dealing with a t-test question. Do you get? Now remember I said from the beginning that z-test when the population variance is known, z-test used when the population variance is not known. So now when the population, we're using it when the population variance is not known. So now, how do we find the critical value for one-tail test? The first step is you first identify whether it is a one-tail or two-tail test. The second one is you find your level of freedom. Now, how do you find your level of freedom? Remember from the beginning, I told you that level of freedom is n minus 1. Okay, so now where the n is the number of sample size. Then the third step is you identify your level of significance. So now we're looking at an example that has to do with how to find your critical value for a one-tail test when it is in a t-test situation. Now, in this example, we're giving our null hypothesis to be greater than 56 and our level of significance to be 0.1 and our n to be 4, and it is in a t-test situation. Now we are asked to find the critical value. How do we find it? Remember, step one, we said that we identify whether it is a one-tail test or a two-tail test. Now in this scenario, we can see that from the question which says greater than, that means it is showing a direction, and as far as it's showing a direction which is greater than, it means it is a one-tail test. So I've been able to identify that yeah, it's a one-tail test. Then step two, we said that we find your level of freedom. And remember from the start, I told you that level of freedom is n minus 1. Now from the question, our n is given as 4. So what you are going to do is 4 minus 1 to give you a level of freedom. Now step 3, you then identify your level of significance, which is given as 0.1 from the question. Now step 4, you then find 3 under 0.1 on your table. Now, remember from the steps I gave you, I said that the first step will be on your T table, find the critical value using what? The level of significance and what? The level of freedom. So we have already found level of freedom. Now, from this question, we found that level of freedom is what? Is 3. And then the level of significance is what? 0.1. Now, on your table, you then find 3 under 0.1. When you do that, it will give you 1.638. Now you must note, don't do it on a Z table, do it on a T table. So now we're looking at the steps in hypothesis testing. Now, step 1, you state the null and alternative hypothesis. The second step in hypothesis testing is that you state the level of significance. And remember, I told you that level of significance will be given in your question. The third step in hypothesis testing is that you decide on the nature of sampling distribution of the test statistics and obtain its absolute value. The fourth step is that you note the significance of the test, whether it is a one-tailed test or a two-tailed test. And remember, how to identify that it is a one-tailed test is that it will give you the direction, whether it is greater than, less than. But if it is a two-tailed test, it is non-directional, meaning maybe it is not equals to. Now, the fifth step in hypothesis testing is that you use the significance level of test, alpha, the size of the test, and distribution to obtain the critical value from the table. Then the sixth step in hypothesis testing is that for a one-sided test, we use alpha, and for a two-sided test, we divide that alpha by 2. Now, the seventh step in hypothesis testing is that for the t-test, you need a degree of freedom. And remember, it's noted by what? N minus 1. Now, the eighth step in hypothesis testing is that you compare the absolute value of the test statistics, which is either the z-test, the answer you got from your z-test, or the answer you got from your t-test, okay? And the critical value obtained from the table. So what am I actually trying to say? You compare those values together in order for you to take your decision. Now, what do I mean by taking your decision? That's the step 9. So now, if the critical value is greater than your test statistics, which is also known as your calculated value, accept the null hypothesis. But if your critical value is less than the test statistics, you reject the null hypothesis. Please take note of that. And with this, I can promise you that as far as you are able to master the steps in hypothesis testing, any question given to you, you'll be able to solve it.